Hi guys, today we're going to do a couple examples, one on counting and one on probability. So here's our counting problem. There are 9 people on the standby list for a flight. At the time of boarding, it is determined that 3 of the standby passengers can get a seat on the flight. And we want to know how many groups of the 3 standby passengers can be selected to board the flight. So our first step when we're doing a counting problem is always to determine if order matters, and that will tell us which formula to use. In this case, we know that order does not matter, so we can determine that by thinking about if, say, we chose 3 passengers from that group of 9 and their names were Ann, Bob, and Charles. We know that the group of Ann, Bob, and Charles and the group of Charles, Ann, and Bob is the same group. So the order that we list the group that can board the flight does not matter. So whenever we have an order that does not matter, that's automatically a combination, so we use the combination formula. So here is our combination formula. It's equal to n factorial over r factorial times n minus r factorial. So in this case, our n is 9 and our r is 3. So combine them into the formula, we get this situation. Whenever I have this situation, I always cancel the larger factorial in the denominator with those terms in the numerator. So when I cancel the 6 factorial with the 6 times 5 times 4 times 3 times 2 times 0, all we're left with in the numerator is 9 times 8 times 7. The 3 factorial turns out to be 3 times 2, and I can cancel a 3 with one of the 3's in the 9 and a 2 with one of the 2's in the 8, left with 3 times 4 times 7, which is 84. So since this is a word problem, we always like to answer the question in the form of a sentence. We would say there are 84 different groups of 3 standby passengers that can be selected. Alright. Here's our probability example. So our question is, when we're playing blackjack, what is the probability of being dealt a 20 in your first 2 cards? That is, you are dealt 2 cards both having a value of 10. So we're assuming that the likelihood of being dealt any card is identical to any other card. We're not counting cards. We don't know what's been dealt already, so we're just going to assume that any card has equal likelihood of coming than any other card. So we have an and situation because we need our first card to be a 10 and we need our second card to be a 10. So this is going to be a situation where the value of our second card is not dependent on the value of our first card. So we've got our independent situation. So and as always, the probability of a 10 and a 10 is equal to the probability of a 10 for the first card times the probability of a 10 for the second card. So we know that there are 16 cards in a normal deck that have a value of 10. We've got the 10s, the jacks, the queens, the kings. There's 4 of each. So for our first card, the probability that our first card is the 10 is going to be 16. Those are the total number of successes over a 52, which is the total possible outcomes. When we reduce that fraction, we get 4/13. This probability of the second card is a little bit different because if our first card is, say, the Jack of Spades, we cannot have the Jack of Spades as the second card because there's only one in the deck. So if that's the case, we need to take that first card out of our successes and our total outcomes. So we now have 10 or 15 more cards that have a value of 10 because we took out one of the 10s that we already had in our first card, and we have 51 cards left to choose from because we had to again take one out for our first card. So 15 over 51, we can reduce that. Looks like they're both a multiple of 3, and when we reduce that down, we get 5/17. So now we just multiply the 2 fractions together. This is the probability of getting a 10 on the first card. This is the probability of getting a 10 on the second card, and it doesn't look like we can cross cancel anything. 13 and 17 are both prime, so we just multiply straight across. We get 20 over 221, which is about 0.09. So the probability of getting a 20 dealt to us in our first two cards is about 9%, and that's not very big. So if you're a blackjack player, you might want to take that into consideration. Okay, that's all for today.